Alrighty, so today we are going to be going over in depth isosceles and equilateral triangles with our two-page document. I keep referencing the two-page document because in one of the earlier videos I had a worksheet that I was convinced was only one page and I was going to have to figure out what I was going to do. Let me zoom in a little bit. I was going to have to figure out what I was going to do to keep the class occupied. And then I looked over and realized that it was actually 2 pages long and I didn't have to worry about it. So I, I don't want to say that I'm taking it personally that the author of each of these worksheets is reminding me in bold print that it's a 2 page document, but well, I don't want to say it, but I kind of am. So we're just going to move on from here. So again, we're going to be focusing on isosceles and equilateral triangles. We're combining, excuse me, I'm going to fix the camera here a little bit. We are combining isosceles and equilateral triangles because there really isn't a lot for, I'm sorry, this is going to just bother me. Bother me until I fix it. All right. Because we're combining isosceles and equilateral because there isn't much for equilateral. There really isn't a lot for equilateral to do because once you kind of figure out the equilateral's trick, that's pretty much it. Isosceles has a couple of tricks to it also, but I mean, pretty much you can't fill up a whole lesson with either one of them, so you got to put them together, and then you'll have a whole one. So let's go ahead and get started. So find each missing measure. So remember, if you have an isosceles triangle, you have two equal sides here. That means that the two angles that are opposite those two equal sides are going to be equal. So I've got 54 degrees here. That means I'm going to have 54 degrees for angle U. So what does that mean for angle T? Does that mean that there's a super secret trick to figuring out angle T with the isosceles triangles? Not really. Basically, what I'm going to do is I'm going to take angle T. What I'm going to do is I'm going to take the two angles that I know down here are equal. Now I'm just going to subtract them from 180. So it's going to be 180 minus 54, and whatever's left over, in this case 72, is going to be the top of it. So again, you're going to have the top angle here, which is going to be above the two legs, and that's going to be different from the two angles that are going to be underneath it. So two angles of the same measurement, and then a third one that's going to be different. So we can kind of see that played out here on this third side. Kind of see that one played out here with this one. This angle is going to be 28. So obviously it's 28 because it's written as 28. So what that means is, if you remember the angles of the triangle, if you have 28 here, then that means that you have 180 degrees minus 28, which is 152. That means that these two angles have to come up with 152 degrees of measurement between the two of them. Here's the thing. Because it's an isosceles triangle, these two sides are equal, which means these two angles are equal. There we go, had kind of porky pigged it for a second. Because those two angles are equal, that means that 152 is divided evenly between the two of them. So that means both of them equal 76, which is equal to 152 divided by 2. My research assistant did that outside of camera view. So here we are again. So it's kind of the same thing as the previous problem, except kind of in reverse. Now we've got, well, for one thing, one of the other things that we have to deal with, I've got 23 here, 23 here. So these are the two angles. Opposite the 23-degree angle is a length of 18 inches. All right, that's perfectly fine. If you remember up here, having the two sides that are equal to each other means having the two angles that are equal to each other. Well, the opposite holds true also. If you have two angles that are equal to each other, the sides opposite them will also be equal. So if 18 inches is equal, it corresponds to a 23-degree measure with this particular triangle, then that means that this side length, EF, is also going to be 18 inches. So now all we have to do is figure out what the measure of angle F is. That one's also going to be relatively straightforward because I know that the whole triangle is 180 degrees. I know that this angle is 23. I know this angle is 23. It's 23 minus 23. So that leaves me with 134. And there we have it. That is the isosceles triangle problem. And then for this one, this is our equilateral triangle. And the measure of the interior angles of an equilateral triangle are 60. There's no mystery about it. There's no majesty about it. There's no, there's no hidden anything about it. They're 60. Equilateral triangle, 60-degree angle. Sides can be anything. The sides can be any measurement. If you know the measurement of one side, that's all three of them. But the internal angles, 3 60s. Just that's it. I've spoiled it all for you. All right, so find the value of each variable. So 78, 78. So what they did here was they indicated that these two sides are the sides that are equal to each other. So by putting the 78s here, they're showing that the sides opposite the two congruent angles. So this side is opposite the 78. This side is opposite 78. So that means that these two sides we can set them equal to each other. So 10x minus 1 equals 4x plus 23. I'm going to take 4x from both sides. That gives me 6x. Then I'm going to add 1 to both sides. Gives me 24. So x equals 4. Oh. Oops. As I'm sure I've mentioned before, if you set these problems up correctly, if you set these problems up very correctly, the answers are usually pretty straightforward and pretty simple integer solutions. So if you're getting a decimal or you're getting like a repeating fraction or something like that, you may want to check to see how it's set up. Let's see. So for this one, I've got another isosceles triangle, which is weird because that's what the homework assignment is. And I've got homework assignment. And I've got 104, I've got 9x minus 25. Okay, so again, got an isosceles triangle, so I know that these two angles are going to be equal to each other, but I can't set up an equality because I don't know what they are, except I can figure it out. So I've got 180 degrees inside each one of the triangles, as we hopefully know by now by heart. And I'm going to subtract 104 from 180. So that gives me 76 degrees. 76 degrees between each of these two angles. So this plus this equals 76 divided by 2. So that means 38. So each of these angles is 38 degrees. So 38 plus 38 plus 104 equals 180. I encourage you to check it out on your own. But for me, I am going to keep going. 9x minus 25 equals 38. I'm going to add 25 to both sides, so that's 50, 63. X is going to equal 7. And there we go. All right, for this next one, we kind of have the opposite situation of the one we had before, so I'm going to just kind of leave that one sort of in frame while I solve this. Before we had the angles indicating that the sides were congruent. Now we have congruent sides indicating that the angles are congruent also. So the relationship between the angles and the sides is a reciprocal one. So if you have two sides, that should tell you that the angles are equal. And if you have two sides that are congruent, that should tell you that you have two angles that are congruent on the same triangle. And if you have two angles that are congruent, that should tell you that you have two sides that are congruent on the triangle as well. So because they're congruent, that means I can set up this equality to solve for x. So 8x minus 55 equals 5x minus 7. I'm going to move x's to the one side, so that gives me 3x equals And then -7 plus 55, 48. So x equals 16. And there we go. All right, we're doing pretty well here. And if you remember, 4x plus 8 equals 60, because this is an equilateral triangle. 4x equals 52. X equals 13. And we're moving on. Equilateral triangles. It's not that I don't have any respect for them. So moving on. We have another equilateral triangle. Because it's an equilateral triangle, it means that the interior angles, as I mentioned before, are always 60 degrees. But it also means that their sides can be anything. But whatever they are, they're all equal. And so if you have so even if you have an x measurement for each of the sides, you can set any two of the sides equal to each other and solve for x. So seeing that I have one angle is 60, one angle is 60, is it possible that I have an isosceles triangle? Yes, it is 100% possible I have an isosceles triangle, and this side is equal to this side. That is 110% that is 100% possible because we're in the isosceles unit. We have two equal angles. You know, what else do we need? But the fact is that if we have 60 here and 60 here, we subtract both of those from 180, we're left with 60 here. And so is it technically isosceles? Technically, yes, because two sides are equal and the opposite angles are equal, but it's also equilateral. And so that means that all of the angles are equal, all of the sides are equal. So I'm going to set up the equality in that spirit. So 11x minus 89 equals 7x plus 19. Move all the x's over to one side. That gives me 4x equals 89 plus 19, 108, divided by 4. X equals 27. And there we go. And that's how that's what we get. Alrighty, and with this one we're back to isosceles triangles. So I'm not gonna, there we go, get rid of that. So again, I'm not gonna say it's back to triangles I respect. So with this one, we're back to isosceles triangles. We're trying to figure out what this angle measurement is. Well, we're trying to solve for x, but in order to solve for x, we have to figure out what this angle measurement is. We have an isosceles triangle, and it's the tip of the isosceles triangle, so that means that these two angles at the base are going to be equal. So all that means is we have to take 180 minus 29 for that one, and then also minus 29 for this angle also. So that leaves us with 122. So 11x minus 60 minus, that's worse looking, minus 65 equals 122. This angle has to be 122 because 180 minus 29 minus 29 equals 122. That's what's left over here. So 11x minus 65, 122. Plus 65 gives me 11x equals 187 divided by 11. X equals 17. And there we go. We're doing pretty well here. And because I remembered, moving on to page 2. Ooh, I always kind of like these. I always like these here. So, all right, ABC is isosceles. So I will, and DBE is equilateral. Find each angle measure. Oh, that is nice. All right, okay. So what this means is angles 4, 5, and 6 are going to be 60. So 4, 5, so 60, 60, 60. Angles 3 and 4 angle 3 is going to be 120 because 3 is a supplement to 4, plus 3, kind of applying in another theory. 3 is the external angle to this triangle, and it's equal to the opposite angles added together, which is 60 plus 60, so that's another reason it's 120. 8, by the same reasoning, is also 120. So let's see. Because it's isosceles, I know that I can set 9x minus 47 equal to 4x plus 3. And this may not sound like a big deal, but what I can do is solve for x and then plug it back into one of these equations to get an actual number. So 9x minus 47 equals 4x plus 3. I don't know. So 5x equals 50. Oh, therefore x equals 10. All right. So that means for angle 1, so if x equals 10, that means for angle 1 equals 43. That means that angle 9 also equals 43. All right. I'd be willing to bet that I'd be willing to bet that 2 and 7 are equal, based on some congruency statement that I'm forgetting, but I can't really remember a good one that I can. Oh, angle side. Yeah, yeah, angle side. So all I have to do is solve for one of them, and I'll get the other one. So angle side. Angle 8 and angle 3 are equivalent, so 120, 120. Angle 9 and angle 1 are equivalent, so 43, 43. And then CB is equal to BA because CB and CA are part of an isosceles triangle. So all I have to do is solve number 7, and I'll get number 2 immediately because of applied learning. All right, so let's see. So 180. So 180 minus 120 minus 43. That gives me 17 for number 7, which also gives me 17 for number 2 because they are congruent parts of congruent triangles. Woo! There we go. All right. I like problems like that. Those are always a lot of fun. I like those. All right. Let's see. A, B, C. If AC equals CB, let's see. I'm looking at all the rest of these. The rest of these are all isosceles triangles. So this is actually going to be a good opportunity to demonstrate good practices when it comes to solving isosceles triangle problems. With the previous worksheet, it didn't really help because we were solving angle problems. So you didn't really need the drawing. I did it because it's good practice, but now this is actually a very, very good reason to do it. So we'll go ahead and get started. So with a triangle ABC, so I'm going to draw out the triangle. Before I put any of the points in, I want to see what the equivalent sides are. So AC is equivalent to CB. So I've got C in both of the legs. So what that means is I'm going to put C at the top, and I'm just going to put A and B at the bottom in whatever order I want. It doesn't really matter. And so AC is equal to CB. Measure of angle A is 3x plus 18. Measure of angle B is 7x minus 58. And then C is 2x minus 8. Find the value of x and the measure of each angle. Now, if you've done a bunch of these problems, do you need the drawing? Not necessarily. Do you need the drawing? Not necessarily if you're good with visualizations. However, again, triangle ABC, you just get the side length. You just get the sides that are equal to one another. Without the drawing, you might set the angles incorrectly to one another. You may say that angle A equals angle C, which will give you a wrong answer. You'll spend a lot of time trying to solve through it. It is just worth the time saving. It is just worth the time to draw out the picture, because now I can just go straight to 7x minus 58 equals 3x plus 18. That gives me 4x equals, and then 18 plus 58, 76 divided by 4 is 19. Now, again, because it's isosceles triangle, all I have to do is find two angles. I have to find this angle, I have to find this angle up top, because these two are equal. I just have to find the one. So 3 times 19 plus 18 equals 75. So A and B are both 75. And then C is 2 times 19 minus 8, 30. There we go. And those are your, there we go. Those are your answers. So again, it is worth the time to just draw it out and just have it there so you can say, oh, these angles, oh, these sides, and just do it that way. All right, so we'll go along here. We've got another isosceles problem here. QRS, QR is equal to RS. So again, I'm looking at this. I've got QR equal to RS. R appears in both of them. So I'm going to put R at the top of the triangle. Angle Q is 8x minus 17. R is 19x plus 4. S is 5x plus 1. And again, find the value of x and the value of each missing angle. Yeah, once again, because I took the time to make the drawing, I can set the equality immediately. 8x minus 17 equals 5x plus 1. That gives me 3x equals 18, x equals 6. I mean, I'm not going to talk about the drawing again, but by setting up the equality correctly, I can do all of the math super fast. And so 5x minus 8, 3x, 17 plus 1, 18, x equals 6. So it's, well, x does actually equal x, but it's not going to get you full credit on that one. So let's see. So for Q, 48 minus 17, that's going to be 31. And then S is also going to be 31, because Q and S are again the base of the base of the isosceles triangle. They're going to be equal to each other. So I just have to find R now. So 19 times 6 plus 4, 118. And there we go. That is the second one. For the next one here, let's see, we've got in KLM, if angle K equals angle L. All right, so this one's a little bit different. So I've got KLM, if angle K equals angle L. So in this case, I've got K, I've got L. I want angle K to equal angle L. Because I'm working with an isosceles triangle, if the two legs are equal, if I'm dealing with two equal legs, I want to make sure that I put the common point at the top of the triangle. That way I know where the base is every single time. If I'm given two equal angles, I want to set those at the base every single time as well. That way, again, I know where everything is. I don't have to do any guesswork. I know where everything is. This is just kind of my system of doing things. It's a consistent process. That way I don't have to worry about making math errors. I don't have to worry about a process or anything like that. So let's see, KL equals 9x minus 40, so 9x minus 40. LM is 7x minus 37, all right. And KM is 3x plus 23. All righty. Find the value of x and the measure of each side. Well, the sides opposite our two congruent angles are also going to be congruent, so that means I can set up 7x minus 37 equals 3x plus 23. So moving like terms together, that gives me 4x equals plus 23, 60. And I think that's just 15. Yep. And so again, I just have to solve for one of these two sides. So 45 plus 23, 68. So MK is 68 and ML is 68. KL is going to be 15 times 9 minus 40, and it's going to be 95. The only issue with sides is you really don't know if you have sides right or wrong until you get them graded. With these ones up here, with the angles, with these points here, with this angle and this angle, if you add them up and you don't get 180, you know you've made a mistake. The only downside with the sides and these isosceles triangles is you really have no idea whether or not you've made a mistake or not. I mean, there's the triangle side theorem where if you add up two of the sides, if you add up the two shorter sides, if they don't at least equal the longest side, then you have an impossible triangle. You can do that, but it rarely matters at this level. Um, so yeah, that's the hardest part. But again, the way the author of these pieces works, if it's not a whole number that doesn't just straight pop out after the problem, then you probably got an issue there. All right, so x, y, z. Angle x is congruent to angle z. So I've got x, z. So that means I'm going to put y at the top. Xy is 13x minus 21. YZ is 8x minus 6. And XZ is x plus 4. All right, find the value of x and the measure of each side. All righty. So again, the side opposite the two angles are going to be congruent. So that means I can set up 13x minus 21 equals 8x minus 6. So combining like terms, that gives me 5x equal to 15, x equals 3. So there we go, we've got x equal to 3. So let's start plugging it in, getting some sides here. So I'll say 3 times 8 minus 6, so 18. So yz is going to be 18, and so is yx. And then xz is going to be 3 plus 4, so 7. All right. And that should do it. So again, I cannot emphasize enough the value and importance of just taking the time, especially with isosceles problems. Just draw the picture. Seriously, just draw the picture. It doesn't take any time, and it eliminates the source of so much error.